Welcome, class. Today, we're going to talk about a quiet but massive revolution in power electronics. We've gone from these big, clunky, separate components to incredibly smart, all-in-one modules. And trust me, this isn't just a small tweak. It's a giant leap that literally powers almost everything in our modern lives. Let's break down exactly how that happened. Okay, so here's the game plan for this explainer. We're going to start with the old way of doing things, the really complex stuff. Then we'll look at the first big step toward making things simpler with power modules. From there, we'll dive right into the smart revolution, actually pull apart a smart module to see what's inside, see where they're hiding in plain sight, and then wrap it all up with why this integrated future is so important. To really appreciate how sleek things are now, we have to rewind the clock a bit. Before these smart modules came along, building a power circuit was a totally different beast. We're talking about mind-boggling complexity, huge circuit boards, and a ton of hands-on work. This slide just nails the difference. On the left, think about building a car engine from scratch. You're bolting on every single piston, every valve, every spark plug, one by one. It's tedious. On the right, it's like getting a complete pre-built engine block dropped right into the car. That's the leap we're talking about here, from a complex piece-by-piece puzzle to a streamlined, elegant, all-in-one solution. So, what was the first logical step in this whole evolution? Well, instead of forcing engineers to juggle dozens of individual power-hungry parts, they started bundling the core components, the real brawn of the circuit, into a single meat package. And this was a huge step forward. It made manufacturing way simpler, assembly got easier, and it even helped with managing all the heat. But, and this is absolutely the most critical point, the module itself had no intelligence. It was all muscle, no brain. It did what it was told, but it couldn't think, it couldn't react, and it certainly couldn't protect itself. Okay, now this is where the real magic begins. This is where engineers started asking a really simple but incredibly profound question that would totally change the game for power electronics. And that question right there on the slide, it kicked off a revolution. It led directly to the birth of what we now call intelligent power modules, or as we often say, smart power technology. This definition just perfectly captures that amazing fusion of brawn meeting brains. We're not just packaging components anymore. We're creating a whole self-sufficient system in one little block. It's a single device that can handle incredible amounts of power, while also keeping an eye on its own health and communicating with the rest of the system. So what is actually going on inside one of these smart modules? Let's peel back the layers and take a look at the anatomy of this technology, because this is really the heart of how it all works. I want you to think of it as the ultimate intelligent gatekeeper. It sits right between the power source, say the battery in an electric car, and the load, which would be the motor. Its one and only job is to manage that energy flow perfectly, making sure that motor gets exactly the right amount of power at the exact right time, all while keeping everything running safely and efficiently. This table here breaks the whole thing down into 4 key jobs. First up, you've got the power devices, your MOSFETs, your IGBTs. That's the muscle, doing all the heavy lifting, switching all that high power. Next, you have the power control, which is kind of like the coordinator telling the muscle precisely when to flex. Then you've got the sensing and protection circuits. This is the module's nervous system, constantly on the lookout for danger. And finally, the interface. That's the communicator, letting the module talk to the main computer of whatever device it's in. Now these are the module's built-in reflexes. It's self-preservation instincts. Over temperature protection, that's way more than your laptop's fan spinning up. This thing can shut itself down completely to prevent getting fried. Overcurrent protection is like a tiny, super-fast, intelligent circuit breaker that trips internally to protect itself and whatever it's powering. It's this whole suite of protections that makes these modules so incredibly tough and reliable. Okay, so this theory is all well and good, but where does it actually pop up in the real world? Well, the truth is, once you know what you're looking for, you realize these smart modules are absolutely everywhere, quietly making our lives better, more efficient, and more reliable. That smooth, instant, powerful acceleration you feel in an electric car? That's a smart module managing a massive flow of power. Or how about the inverter for your rooftop solar panels, flawlessly converting DC power to the AC your house uses? Even the super quiet, efficient motor in a new washing machine or air conditioner. Yep, you guessed it, probably has one of these inside. They are truly the unsung heroes of our modern electrified world. All right, let's pull this all together. If there is one and only one big idea you remember from this whole explainer, I want it to be this. This quote you see on the slide, it just says it all, doesn't it? The major trend is integration. But it's not just about making things smaller for the sake of it. No, this is a strategic move to make our power system smarter, more reliable, way more efficient, and at the end of the day, just flat out better in every single way. So if you walk away with just one mental picture, let it be this one. Smart power modules are where high-power brawn meets low-power brains. It's that beautiful fusion of raw brute strength with the delicate intelligence to control it and protect itself. And that powerful combo, that's the engine driving so many of the technologies we now take for granted. And so, I'll leave you with this final thought. As our world gets more and more electrified, more automated, what new doors open up when every single component has its own built-in intelligence? I mean, think about the impact on things like medical devices, deep space exploration, or the future of our entire energy grid. The possibilities, well, they're pretty much endless. Thanks for your attention.